Good afternoon, fellow Patreons. What you see here is Lisa. It's a cyborg that I'm building. She has a bionic leg and a bionic arm, and also a wrist that moves. And in addition, her waist is bionic. She can turn 0 to 360 degrees, so she could be walking forwards and be facing backwards if she wanted to. Here you see the part of the bionic arm mechanism. As you can see, it has a motor. It's a very powerful 12-volt motor that has a built-in quadrature encoder. So it's a very precise motor that allows the arm to move very accurate movements. It's not very fast necessarily, but it's pretty close to human speed. But it can move very precise movements or angles. So she could bend her arm to easily within a degree, or even better, half a degree. Because the motor has a built-in quadrature encoder that's very accurate. It's 1 part to 4,096 parts. It's much more accurate than the standard VEX quadrature encoders that are only good to like 360 degrees. 1 part in 360. The same is true with her bionic leg. The motor on the bionic leg is a little bit bigger, and it doesn't have a built-in quadrature encoder like her arm, but I can add a quadrature encoder to it. When I get a chance, I'm going to do that, so that then the leg would also be able to move very accurate positions. Right now the leg can move pretty accurately on its own, but with the quadrature encoder it would be able to move very precise angles, at least to a 1 degree resolution. Both the arm and the leg are built mostly of VEX construction system components, including the structure, metal rails, etc. But I do have additional brackets as well as Lazy Susans that I just bought at the hardware store. So you can use pieces of scrap metal, or you can go to the hardware store and pick up brackets and everything else to assemble a leg and an arm the way I did. Here you see a picture of the original Bionic Woman, Lindsay Wagner. She was in the TV show The Bionic Woman, which was spun off from the original $6 Million Man TV series in the mid-70s. That one had Lee Majors playing Steve Austin, and this one has Lindsay Wagner playing Jamie Summers, who was bionic. She had a bionic arm and a bionic leg. So it's very similar to Lisa here. Here you see the other part of the VEX construction system components, which are the VEX Cortex microcontroller, as well as the VEX game controller. The VEX Cortex is now considered obsolete because Innovations First Incorporated, who makes these construction system, the VEX construction system, has recently upgraded to a V5 product, as well as components and sensors that work with the V5. But the VEX Cortex is a very powerful ARM-based microcontroller, and it works beautifully for this application. It's powerful enough, and has plenty of speed and plenty of memory. And it runs a language called Robot C, which can run in parallel, can run tasks, which is very useful in robotics. These VEX construction systems are used worldwide in high school and grade school and college and even university contests that are held worldwide. The students build robots to solve all sorts of very complicated mazes and problems and games, and they have to use strategy, and they have to beat other teams using just autonomous robots. So it's a very powerful construction set that allows you to do this. It's much more robust than the original erector sets, which were pretty good in their own time. In fact, I still use some erector set components that are not even available to the VEX construction system, such as a lot of pulleys and gears, metal gears instead of plastic gears, etc. This system originally, was originally a mannequin for a store that I was going to animate for the store. It was a clothing store that wanted to show off different designer outfits and have an animatronic display that would just, the mannequin would just wave periodically or move a leg or lift her arm, just not continuously, but every like minute or so, to get the customer's attention and try to get them to buy the clothing that she was wearing. So the arms and legs had to be powerful enough to lift some of this clothing, which can sometimes be pretty heavy. Designer, like a dress, and could have a lot of weight to it, depending on the material being used and everything. Clothing can weigh a lot. So it had to be strong enough to handle that. And Lisa can definitely do all of that. She can model a dress. She can twist it. She can even do like a go-go dance with an outfit, and get somebody's customer's attention in the store. And this was going to be in a safe area, such as the glass display in the front of the store, so that no clients could touch it or no kids could be near it, because it's a robot. It's not a toy, and it could possibly injure somebody nearby. So it has to be, in a safe area. The robot has to have its own workspace. In addition, her eyes are going to be animated eventually. They are, I'm going to put a servo mechanism that allow the eyes to move, as well as to be able to nod the head up and down and turn sideways, left to right. So she'll be able to have that kind of animation too. Not unlike the Disney animatronics displays found in Pirates of the Caribbean, except that those are much better animations, because Disney, has a lot of resources and a lot of expertise doing that kind of animation, so that they almost look lifelike. This one still looks like a mannequin. It's just that she can move an arm or move her leg periodically. Another application for this animatronic display would be sort of like a haunted house display, where you have the mannequin dressed up and scaring people going into the into the haunted house. Lisa has another sister, which was also going to be part of the store display, and her name is Angela. Now, Angela is a much more powerful animatronic device than Lisa. Angela can actually lift pretty heavy objects, and her leg and her arm are very strong, but they're not as precise. They can't move precisely the way Lisa does. You could almost think of Lisa as a walking 3D printer, because some of the technology used to animate her is derived directly from 3D printing devices. In fact, I plan to put 2 cameras in place in her eyes, so that she'll be able to see stereoscopically, and be able to send the images to like, let's say, the store owner to show what the dummy is seeing. In addition, she the way she can turn and everything, she can use photogrammetry to 3D scan a person or an object. That's a new feature that I'm building into her. So she'll be able to do 3D scans of objects, and maybe even a person if the person was standing still long enough. Lisa has a new mission now that she lost that job at the store because it went out of business. Her new mission is going to be a surgeon for NASA on the Artemis rockets that'll be going to the moon to start a moon base. And she'll also be working on the International Space Station. And she'll be the residing doctor and surgeon because of her very accurate arm positioning and leg positioning and waist positioning system. So she'll be like the onboard surgeon, or robo-doc, so to speak, taking place of Dr. McCoy on Star Trek. And she'd be able to perform surgeries, appendectomies, heart surgery, open heart surgery, etc., very accurately, using her arm and her leg to position her body correctly, and even her waist.